We live in extraordinary times. Technology is evolving at a breakneck pace, reshaping the world around us. One of the most transformative forces driving this change? Machine learning. It's no longer a futuristic concept confined to science fiction. It's here, it's real, and it's changing everything. From the way we shop to the way we diagnose diseases, machine learning is leaving its mark on every aspect of our lives. So, what exactly is machine learning? In essence, it's about teaching machines to learn from data without being explicitly programmed. Instead of giving a computer step-by-step instructions, we feed it massive amounts of data and let it figure out the rules on its own. Imagine creating a program to identify different types of flowers. Traditionally, you'd write code defining features like petal shape, color, and size. With machine learning, you provide thousands of labeled images, and the algorithm learns to classify new, unseen flower images. The machine learning algorithm analyzes these images, identifies patterns, and builds a model for accurate classification. Machine learning isn't just a fascinating technological advancement, it's a game changer across industries. The reason it's so impactful now is due to the convergence of several key factors. We're living in an era of unprecedented data explosion. Every day we generate astronomical amounts of data through online activities, social media, and sensors. This massive data is the lifeblood of machine learning. The more data we have, the better we can train algorithms to make accurate predictions. Couple this with exponential growth in computing power and affordable cloud resources, and machine learning thrives. There's a growing demand for intelligent solutions across industries. Businesses leverage machine learning for automating tasks, improving efficiency, and creating innovative products. From healthcare to finance, transportation to entertainment, machine learning is revolutionizing every sector. Machine learning is about teaching machines to learn from data. But how does that happen? At its core, machine learning is all about pattern recognition. Just like humans learn to identify patterns, machines can be trained to do the same on a larger scale. Think about how you learn to ride a bike. You learn through trial and error, observing what worked and what didn't. Machine learning works similarly. We feed the algorithm massive amounts of data and let it learn from its mistakes. The algorithm uses mathematical models to analyze data, identify relationships, and build a predictive model. There are different approaches to machine learning: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning, guiding the machine with labeled data. Imagine teaching a child to identify different fruits by showing them labeled examples. This is the essence of supervised learning. We provide the machine with labeled data, and the algorithm learns to map inputs to outputs. In flower classification, we provide labeled images, and the algorithm learns to identify features distinguishing each flower type. Once trained, the algorithm can predict the type of new unseen flowers. Supervised learning is used in image recognition, spam filtering, medical diagnosis, and stock price prediction. Within supervised learning, we have classification and regression tasks. Classification assigns data points to categories, while regression predicts continuous values. Unsupervised learning, unleashing the machine on unlabeled data. Imagine giving a child a basket of fruits without labels and letting them group by similarities. This is the idea behind unsupervised learning. We provide the machine with unlabeled data, and it discovers patterns on its own. Unsupervised learning is about exploration and discovery. It's used when we don't have labeled data or want insights without predefined categories. Applications include customer segmentation, anomaly detection, and recommender systems. Common tasks are clustering and association, like grouping customers by purchasing behavior. Reinforcement learning, training machines through trial and error. Imagine teaching a dog a new trick with rewards for correct actions. That's reinforcement learning. We let the machine interact with an environment and learn through trial and error. The algorithm or agent takes actions and receives rewards or penalties. The goal is to learn a policy to maximize cumulative rewards. It's like playing a video game to achieve the highest score. Applications include robotics, game playing, and optimizing traffic lights. Unleashing the power of algorithms, the engines of machine learning. We've explored how machines learn supervised, unsupervised, and reinforcement learning. The heart of machine learning is algorithms. Algorithms are mathematical instructions that allow computers to learn from data and make predictions. Choosing the right algorithm is crucial for success. The choice depends on the problem, data size, and desired accuracy. We'll demystify popular algorithms, understand their strengths and weaknesses, and see real-world applications. Get ready to unlock the true power of machine learning by diving into algorithms. Linear regression, finding order in the chaos of data. Imagine predicting a house's price based on its size. You might plot size and price on a graph and notice a trend, a straight line. This is linear regression. It's a supervised learning algorithm assuming a linear relationship between input and output. The goal is to find the best fitting line that minimizes prediction errors. This line can predict the price of new houses based on size. Linear regression is used in predicting sales, stock prices, and understanding marketing impact. Decision trees, making sense of complex decisions one branch at a time. Imagine deciding whether to run based on weather factors. You create if-then-else rules. If temperature is above 30 degrees, don't run. This is the idea behind decision trees. Decision trees use a tree-like structure to model decisions and consequences. Each node represents a test, each branch an outcome, and each leaf a class label. The algorithm learns decision rules from labeled data by splitting it into subsets. Decision trees are used in credit risk assessment, medical diagnosis, and marketing strategies. Neural networks, mimicking the human brain for advanced intelligence. Imagine a network of interconnected neurons in the brain. Neural networks mimic this structure and function. They consist of layers of interconnected nodes or neurons. Each connection has a weight representing its strength. The network processes input data through layers and produces an output. During training, it adjusts weights to minimize prediction errors. Neural networks tackle tasks like image recognition, natural language processing, and playing complex games. The fuel of intelligence. Understanding the crucial role of data. Data is the lifeblood of machine learning. Just like a car needs fuel, algorithms need data to learn and predict. The quality, quantity, and relevance of data impact model performance. High-quality data leads to powerful insights and accurate predictions. Poor quality data can derail algorithms. It's not just about gathering data, it's about collecting the right kind, ensuring quality, and preparing it for maximum value. Understanding data's importance is paramount in machine learning. Section 2. Data preprocessing, cleaning and preparing data for machine learning. In the real world, data is rarely served on a silver platter, ready for consumption by our hungry algorithms. Data preprocessing is crucial for cleaning and transforming raw data into a format suitable for machine learning. Think of it as preparing a delicious meal. We can't feed raw, unprocessed data to our algorithms and hope for accurate predictions. Data preprocessing involves cleaning, handling missing values, and transforming data. This ensures our data is accurate, consistent, and relevant. Feature engineering, transforming data into powerful predictive signals. We've cleaned and pre-processed our data into a well-organized data set. Feature engineering transforms raw data into powerful predictive signals. Like a chef creating extraordinary dishes, we transform data features. Effective feature engineering boosts model performance and insights. Section 4. The Data Algorithm Duet. Finding the right balance for success. We've delved into the critical role of data in machine learning, exploring data pre-processing techniques to clean and prepare our data, and feature engineering strategies to transform it into powerful predictive signals. But it's important to remember that data and algorithms are not isolated entities in the world of machine learning. They exist in a symbiotic relationship, a delicate dance between information and intelligence. Choosing the right algorithm for a specific task is crucial, but the effectiveness of that algorithm heavily depends on the quality and relevance of the data it's trained on. It's like pairing a world-class chef with the finest ingredients. Even the most skilled chef can't create a culinary masterpiece with spoiled or mediocre ingredients. Similarly, a powerful algorithm trained on insufficient or biased data might produce misleading results. On the other hand, a simpler algorithm trained on a high-quality, representative dataset might outperform a more complex model struggling with noisy or incomplete data. Finding the right balance between data and algorithms is crucial for success in machine learning. It's about understanding the strengths and limitations of both, carefully selecting the appropriate techniques for data pre-processing and feature engineering, and choosing algorithms that align with the nature of the data and the goals of the project. Section 1. The ever-evolving landscape. Advancements in machine learning. We've explored the foundations of machine learning, delved into the intricacies of algorithms, and recognized the paramount importance of data. But the journey doesn't end there. The world of machine learning is dynamic, constantly evolving, with new advancements and breakthroughs emerging at a rapid pace. Imagine a bustling city skyline with new skyscrapers constantly being erected, each representing a novel algorithm, technique, or application. That's the exciting reality of machine learning today. Researchers and engineers are continuously pushing the boundaries of what's possible, developing innovative solutions to ever more complex challenges. These advancements are driven by several factors: the exponential growth of data, the increasing availability of computational power, and the relentless pursuit of more efficient, accurate, and ethical machine learning models. These driving forces are shaping the future of intelligence, paving the way for even more transformative applications across industries. In this ever-evolving landscape, staying ahead of the curve requires embracing a mindset of continuous learning and exploration. Let's dive into some of the recent advancements that are reshaping the world of machine learning, from transfer learning to federated learning and the rise of AutoML. Transfer learning, leveraging knowledge one model at a time. Imagine teaching a child to recognize different breeds of dogs. You start by showing them pictures of various breeds. Later, they can quickly learn a new breed by drawing upon their existing knowledge. This is the essence of transfer learning. In machine learning, it involves training a model on one task and using it for a related task. We transfer knowledge to accelerate learning on a new problem. A model trained to recognize objects can be used for new tasks, like detecting defects in manufacturing components. Transfer learning reduces data and training time. It improves performance with limited data. Section 3. Federated learning, collaborative intelligence, preserving privacy. Imagine a world where millions of smartphones could collaboratively train a powerful machine learning model without sharing their sensitive data with a central server. This vision of collaborative intelligence while preserving privacy is at the heart of federated learning. In traditional machine learning, data is typically centralized in one location for training. But in many real-world scenarios, data is distributed across multiple devices or institutions, raising privacy concerns and logistical challenges in centralizing it. Federated learning addresses these challenges by bringing the training process to the data rather than the other way around. Here's how it works. Each device trains a local model on its own data. Instead of sharing the raw data, the devices share updates to the model parameters with a central server. The server aggregates these updates, improving the global model without ever accessing the raw data on individual devices. Federated learning opens up exciting possibilities for training models on sensitive data, such as healthcare records or financial transactions, without compromising privacy. It's also particularly well-suited for scenarios where data is geographically distributed or where bandwidth limitations make it impractical to centralize data for training. Section 4. AutoML democratizing machine learning, empowering everyone. Building effective machine learning models often requires significant expertise in algorithm selection, hyperparameter tuning, and feature engineering. But what if we could automate these complex tasks, making the power of machine learning accessible to everyone, even those without deep technical expertise? That's the promise of AutoML. AutoML, short for Automated Machine Learning, aims to automate the end-to-end process of building machine learning models. Think of it as a smart assistant for machine learning, guiding users through the entire pipeline, from data pre-processing to model deployment. AutoML platforms typically employ sophisticated algorithms and search strategies to explore a wide range of model architectures, hyperparameter settings, and feature engineering techniques. They automatically evaluate the performance of different models and recommend the best performing one based on the specific dataset and task. AutoML is democratizing machine learning, empowering domain experts with limited coding experience to build and deploy models without needing to become machine learning specialists. This accessibility is fostering innovation, enabling businesses of all sizes to leverage the power of machine learning to solve real-world problems. Section 1. The road ahead, machine learning and the future of intelligence. The road ahead is illuminated by the transformative power of machine learning. Machine learning will reshape industries, redefine professions, and revolutionize our lives. The future of intelligence is being written in algorithms and powered by innovation. Imagine personalized medicine tailored to your genetic makeup, self-driving cars navigating with safety and efficiency, and intelligent assistants anticipating our needs. These are glimpses into a future shaped by machine learning advancements, but the road ahead is not without challenges. We must address ethical considerations and ensure fairness in algorithms. The future of intelligence is about creating a better, more equitable, and sustainable future for all. Embrace the future, shape the world. We've journeyed through the fascinating world of machine learning, from its fundamental concepts to its cutting-edge advancements. This is just the beginning. The world of machine learning is vast and ever-evolving. Whether you're a student, a professional, or simply curious, the time to embark on your machine learning journey is now. Embrace the unknown, dive into data, and unleash your creativity to build intelligent solutions. The resources are at your fingertips: online courses, interactive tutorials, and a vibrant community. Experiment, explore, and push the boundaries of what's possible. Your journey begins now.